Okay, I'm going to look at problem 17 from chapter 7. Okay, so this problem is a linear interpolation problem. So you have information stored in a data file, okay, tunnel.dat, and that's on the website, which we'll go and get and take a look at it. It contains some data. It's a flight angle in degrees and coefficient of lift. Okay, so it's a wing inside a wind tunnel, and the angle of the wing or the attack angle of the wing changes, and then they record the data. Okay, and this data is contained within a file called tunnel.dat. So what we're going to do is we're going to use what we've learned previously, chapter 5, how to open files and read data in from a file, and we're going to read that in, and we're going to use our new concept, arrays. We're going to read it into some arrays. And then what we're going to do is we're going to do some processing with that data. And the processing that we're going to do is we want to determine a point or an output, a lift for an angle that's not given. Okay. And the way we're going to do that is that we're going to use linear interpolation for that. All right. And I do have I did post a linear interpolation introduction, so you should watch that. So what I'm going to do in this problem is I'm going to actually, there's a solution in the solution set for this problem. And what I'm going to do is I'm going to use that solution, and I'm going to work through the problem and put comments as I go through and explain that solution. Okay, so the first thing we need to do is go to, Visual Studio. Oh, not the installer. Visual Studio. And we're going to create a new project. Console app. And this is chapter 7, problem 17. Oh. Okay, create. Okay. So first thing I'm going to do is go to the website, or the next thing I'm going to do is go to the website, and I'm going to look down data files, and I'm going to find tunnel.dat. I'm going to download it. And I'm going to save this into, so problem 17. Okay, so mine's already there. You may have to look for it. So like problem 17. And I have mine. This is where my CPP file is located. Actually, I could go in here and say all files. So I need to put it in the same place as my CPP file. So I'm saving it, or the same directory as my CPP file. Okay, so that's good. And the next thing I'm going to do is I'm going to go into the solution set, solutions, and I'm going to go to assignment 7 solutions. And this one I can, really doesn't matter. I can just download it the same place. Okay, so I'm going to do save there. Okay, so now I got those 2 files. All right, so what I'm going to do is I'm going to go into that directory, and I'm going to get the solution set here. Not that, not the dot, the solution set, not .sln file. I go into here. Okay, and here's my solutions. It's going to go down and pull up. Here's problem 17. So I'm just going to grab this one, not with the linear interpolation part, and go all the way down and make a cut. I'm just going to paste this right into Visual Studio. Okay. There we go. Control V. Okay, so now I have that program. So what we want to do here, and I'll just do a save all. Okay. Let me do one more thing here. Let's go in here and let's open up. So say source files. I'll right click here. I'll add existing item, and I'm going to open up that data file Here it is, tunnel.dat. And here we go. At some point. Okay, there's the data file. So I can now go back and forth between the two. Okay. So the data file has, here's the angle and here's the lift. Here's the attack angle and here's the lift. So when it's a negative degree, these are actually cause negative lift, which is actually forcing it down. Then we get some positive angles, 0 degrees, 2, 4, 6, 8, whatever, up by 2. Okay. And so what we're going to do is we want to find, we want to use linear interpolation to find the output or the lift coefficient for angles that are not listed here. Okay. As long as it's between the range, between -4 and 21. Okay. So like, let's say if we wanted to find, we could actually go in here and plug in for 1. If I put in 1 here, it's going to be like basically halfway between these two. Okay. So let's try it and actually run. So let me go back to this. Let me run it and see how it works. So let me run it. And then we can talk about it. Make sure it's good. So I'm going to enter angle. I'm going to say 1 degree. And let me do one more thing here. I'm just going to do this. You could do Control F5, but I'll do this. System pause. Just so it stops, right? So I'm doing it right between the return, before the return in the main function. Let's try again. Okay. Okay, I'm going to put in angle 1. 0.1675. Okay. And if we look back at the data, for an angle of 1, so between 0 and 2 here, 0.1675. Okay, which is like, there. That's halfway between these two. Okay, you can verify that. Okay, so let's go back to the code. All right, let's start from the beginning here. So there's some, there are some comments used in here. First thing you'll see is C standard lib, and there's a warning here. We'll take a look at that. I don't recall why we need C standard lib here just yet, but we'll take a look. But we know we need this for files, right? So here's our include for files. Okay, so we need that. Here's a standard thing, standard namespace. And here's max index. Now the max index, the reason it's 20, and this is a constant, right, because it doesn't change here. This is because there are 20 elements in the file. Okay, so 20 rows. 20 rows in the data file. Okay, so that's why we're doing that. Here is our interpolation function, right? This is the one that's actually going to go. This is the function where we put our equation in to actually calculate what the value of the output is for that specific inputs. Okay, so this is my interpolation function. Okay, and there's 3 things we're going to enter into it, or three arguments or 3 parameters that are defined for this function. One of them is a variable here, and this is actually, this is my new value, right, that I'm trying to find. Like in my example, I said, let's say, in the one we ran, we did it for 1 degree, right? I would pass in 1 here, and then this output of this function, what it would return would be the new coefficient of lift, okay? Now, these 2 things are, these are 2 arrays that are going to be populated with data. Here's my input value, and here's my output value. So these are going to correlate. So like x of 0 is going to be y0. So like this would be index or offset 0 for x, and this would be y offset 0, and then this would be x offset 1, and this would be y offset 1. Okay, so these are all the values of the x's. This would, we're going to populate our input array, our x array, with these values, and then we're going to populate our y array with these values. Okay, then we're going to use those. All right. Okay. So here it is. We're going to declare a couple of arrays. First, we're going to start with my angle array. So angle has angle array contains the first row column in the file. Okay. The coefficient array, and the reason these are defined differently is because in the actual function they use x and y. Out in the interpolate function, in the main function they use angle to represent the input and coefficient to represent the output, or the okay. And this is the coefficient. Oh, coefficient array contains the second column, right? The outputs column in the file. Okay. Okay. Well, this one we're just going to do the usual, right? We open the file. This one is just the if is of course just check to see. Of course, these are my comments, so I'm just putting in here for your benefit to see what these do. See if file exists, right? Exists, or it's in the right location, right? If this doesn't work and it fails each time, maybe you didn't put the file in the right location, or maybe you renamed it improperly. But make sure this works, right? Don't get an error. But this is check to see if the file exists. Okay, so the next thing, data is read in. Okay, so all this does is, here's my tunnel. See, tunnel was the, tunnel is the file stream object. So tunnel is file stream object, which is basically means how we interact, or the program interacts with the file through this file stream object. Okay, so we need that. Okay, so that's done right here. So what does it do? It says, here's tunnel, which is the file stream object. Read the first value into this angle array, and the second value into coefficient array. And what this one basically says, and this is written a little bit different than what we may have written things before. This is pretty efficient way. And this one just, we use for loops a lot of times. This one just says basically keep reading it, keep reading it, keep reading it until you get to the end of the file, right? Keep reading into arrays until EO file is reached, right? End of file is reached. Okay. And this just indexes it, right? So now at this point up to here, you now have two arrays filled with data from that file. Okay. Now here's where you actually go through. There's a comment here. This is where you're prompting the user. The variable the author used was called request. This is this is where you prompt the user, say, oh, okay, enter an angle that you care about. Okay. Now this checks to see, hey, is your request within the correct range? Now the assumption is that of course this data file is in order, right? That everything is this, the first element is the lowest, smallest angle, and the last element, this represents the last element, which is one less than the size, right? Because it always starts from 0. And this is the last element. So it basically says, if you're below, if the angle your request, what you wanted it to do, what angle you wanted to interpolate is outside of, or it's a less than the lowest angle or greater than the highest angle, we can't interpolate it, right? Because there's no upper bound or lower bound for us to work with. So that one we just end and put out a message says, sorry, angle out of range, cannot interpolate. Sorry, try again, okay, next time. Otherwise, what we do is we're going to put out a message saying coefficient lift has been interpolated. Okay. Now, right now, all it is a call to the function. Okay. And we're going to take a look at that function. So this one basically is just, here's my function, which what will happen here is that you're going to pass in the request, and then you're passing in the array, and the other array. Remember, these are passed by values, so here's the angle array and the coefficient array. Okay, and then the request is, what angle do you want to get an output value for, right? So in our case, when I looked at the example, you might have said like, oh, this is the new, whatever returns from this function call is the value that we calculated. Okay. All right, so let's take a look at the interpolation function. Okay, so first thing is, and here's the interpolation function definition. First thing, we start with an index I. Okay. Now, one of the things we need to do here is we actually need to find the value where you're in between. You need to find like the x1 and what I defined, the x1 and x2 or whatever. You need to find the values that are just above it and below it, right? Because otherwise you don't know which 2 points to interpolate between. Okay, so I'll also add this, determines which determines the x values for interpolations, right? Which of course, I'll say x, so I'll say, wait, angles and coefficients for interpolation. Okay. So what this is actually going to do is going to return the, or not what's going to return, but it's going to determine the index or the offset. Okay. And if you remember, these two, each element in this one correlates directly, of the angle correlates directly to the coefficient in this array. Okay, so once you find the coefficients for the angle array, which is this, or not the coefficients, but the once you find the offsets for the angle array, it's the same offset used for the coefficient array. Okay, so that's what this determines. So this will determine the lower and upper limit, right? The x, what I called x1 and x2 that are around it, that you're interpolating between 2 points. Okay, and all it says basically is that when you get above the lower one, all right, then now you know you're in the right range. You don't even need to look at the next one, because once you're above that one, because you're incrementing them through, you're assuming everything's in order already. Okay. Okay. So there are cases where you get an exact match. So that's what this is. Maybe you actually plugged in a value, let's say 0 to 1, whatever. You get an exact match. So for an exact match, don't do any interpolation, just return it. Return coefficient. For requested angle. Okay, so that one isn't even, that's just returning it directly. We don't even need to do that calculation. Okay, so the next one is, this is the actual calculation. So this is my interpolation calculation. Interpolation calculation. Okay, so it's written a little bit differently than the way I wrote it, but here, if you watch, hopefully you watch my intro to interpolation video, but this is like the y-intercept point. This is like what I defined as b. Okay, and I'm just going to say this thing really calculates this, mx plus b, right? That's what this is. It's just a slope-intercept form of an equation. Okay, so what do we have? This is my x value. Okay, that's the value. This is what's determining this x. Okay, so what we need to do is just subtract the one that I want minus my initial one. Okay, so this is the x value. Then what we have is, interesting way it's written is, this is my my slope. I'm sorry, not this by itself, but this, interesting how the author wrote this, but this over this becomes your slope, okay? And if you want to, what I can do here is, let me just rewrite this one thing so you can see another alternate way to write this, which is essentially the same equation. You could write it like this, and it will show up in this form then if you do it like that. But you have a choice. If you understand it the way it is, you don't have to change it. So I'm going to say this, but I'm going to take, I'm just going to do it like this. I'm going to take this, cut this out. I'm going to rewrite it so that it's in this form. So that is this. And then in the slope is really just this part. So I'll do this. So I'm going to do it like this. And what you're going to find is this is going to be exactly the same, except it's easier to match it with what I did. Okay, so this is this times, and then this. Then I divide it like this. So you come up with a division here. And that works out fine. And then the last one is just plus this. Plus. Okay. So here's the alternate writing of this equation. And the reason I'm, let me do it a little bit differently. I'm going to take this and I'm going to put this right here. Just so it's in the same form as the equation that I wrote. Okay, so that should be it. Okay, I think we're okay, right? The first one, oh, the only thing did I keep all of them? I got y minus 1. Okay. So here's an alternate form. It's the same equation, except if it's easier to follow this. So let's go run it and make sure it's good. So let me run it again here. I'm going to run it with this without my form of this equation just to show you it. So let's make sure it still works. I didn't like mess anything up here as I was running it, as I was messing around with it. 1. Okay, 0.165. So that looks good. Now what we'll do is I'll just comment this one out, and I'll put the alternate form in here that I wrote. Okay, where it matches directly. Now you see here's the division operation. Oh, let me do it like this. Yeah, so here's my division. First thing I do is the division, which is my slope. So this is the slope part. Here is the x, and here is the y-intercept. And you know what? I got to put my semicolon here. Okay, let's do that. No, sorry. Not like that. One too many. Okay. So now let's run it. Okay, let's put in 1. Oh, there's an error. Okay, so there's an error how I wrote it. You got to fix it. So here is so you need to write it like this. Here's the I had these two reversed. So here's the slope. This is the rise, the y components, the outputs over the inputs, the difference between those. So here's my slope. That's my m. Here's my x value. Okay, that's what these two are together. There's my value. This is my requested value, right? And here's my value of x that's just before it. And here's my y-intercept, essentially. Okay, so following that form. And we can run it, make sure it works. So for 1, this is what I did previously. Enter. And 0.175. And that's good.